Today we'll be solving absolute value equations, and this is Algebra 2, Unit 1, Lesson 3. Right, the first style of problems that you'll see using absolute values are, which numbers in this set are solutions to the absolute value equations below. So the set includes -3, 0, and +3, and the equations that we're talking about are, the absolute value of x is equal to -x. Let's deal with this one first. And what we're going to do is we're going to substitute each one of these values of -3, 0, and 3 into this absolute value equation, and then simplifying each side of the equation to see if it's a true statement. So the first one we'll do is this. We'll go ahead and stick in -3 in for x here and here. So what's the absolute value of -3? Well, that's 3. And what's the opposite of -3? Well, that's also 3. So 3 equals 3. So -3 is a solution to this equation. Okay, we'll do the same for 0. The absolute value of 0 is 0. And the opposite of 0 is still 0, so 0 equals 0, and so 0 is also a solution to this equation. If we plug in -3 here, or +3, plug that in here and here, the absolute value of +3 is 3, is equal to -3. Well, 3 does not equal -3, therefore the number +3 is not a solution to this particular equation. Okay, and what we're going to be doing is substituting, and you'll do the exact same thing for the second one, and find out that each time you plug in any of these three numbers, the answer does not become a true statement, and therefore we have no solutions from the set that was given. Okay? In writing an absolute or solving an absolute value equation, we're going to have to write two equations. Okay? We'll always take what's the expression right there, put that here and here, and solve for the positive and the negative. And what this is saying is that we're looking for some number that is 5 units away from the number 0. And those numbers could be 5 or it could be -5. Now here's a couple of ways to think about writing the first and second equation. First thing you do is drop the absolute value signs, keep the number on the right side of the equation and equal it. Okay? Second time is to drop the absolute value, change the sign of the number on the right side with the equal sign. Okay? And the expression inside the absolute value sign never changes. So this number inside never changes. We just keep that right the way it is. Okay. So let's go ahead and try this out. Okay. First thing we got to make sure is the absolute value sign by itself on one side of the equation. In number 2, yes it is. So we go ahead and write the expression twice, x minus 7, and write it x minus 7 here again. Okay. And we set it equal to the right number on the right side. And then the second equation, we set it equal to the opposite of that number. So if this is a positive number, it becomes a negative. If it was a negative, it would become a positive. Okay, then we go ahead and solve each of these equations out. We find that x equals 19 and x equals -5. Take these numbers, plug them back into the original equation, and see, does it work out? Okay, -5 minus 7, well, that's -12. Absolute value of -12 is 12, so that works out. Okay, put 19 in for x. 19 minus 7 is 12. Absolute value of 12 is 12, and that works out as well. So these two numbers are solutions to the second equation. Let's try the next part. Okay, and this one, we've got the absolute value symbol here, along with a +7 on the outside. First thing we must do is we have to isolate that absolute value sign before we write the two equations. So the first thing we do is subtract 7 to both sides. Okay, now that we have the absolute value symbol equal to a negative number. Well, wait a minute. I'm looking for a number that has got a value of -5 distance, or -5 steps away from 0. Well, since distance can never be negative, this one does not have a solution. Okay, so if you have an absolute value sign by itself isolated and it equals a negative number, the answer is no solution. Let's check out number 4. Okay, over here, first thing we do is we recognize that there's a -3 along with the absolute value sign on one side of the equation. So what we're going to do is we're going to divide out that constant, because that 3 would be multiplying with the absolute value symbol, so we do the opposite and divide out. Okay, and we get x plus 6 is equal to 12. And now we have the absolute value sign isolated. We write the expression out twice, set the first equation equal to 12, set the second equation equal to the opposite of that number. Solving, we get 6 and 18, and we double check and they both work out. Over here, we have the absolute value sign isolated, but it's also equal to a different expression instead of just a number. Well, it's not bad. We follow the same steps. We write the expression out twice, set it equal to the right side, and set it equal to the opposite of the right side. So we make sure we have to distribute that negative sign in and go ahead and solve for x, and we get -4 and 2/3. Okay. Now, when dealing with absolute value inequalities, okay, we're going to do the same thing. We're going to write two equations. The first equation, all we do is simply drop the absolute value sign after we've isolated it and solve for that. The second time, we drop the absolute value sign, flip the inequality symbol, and change the sign on the right side. Okay, but before we do all this stuff, we have to isolate the absolute value sign by itself on one side of the equation. Well, this one's already done, so on the first equation, we simply drop the absolute value sign, so x is greater than 4. On the second one, we drop the absolute value sign, switch the sign direction, and change the sign on the number. And we've done that. There's nothing else to solve except we just simply graph. Now, when we've isolated the absolute value sign with an expression or a number on this side, okay, we have to follow this rule. If it's a less than or less than equal to, this becomes a conjunction, which means we need some type of overlap within our graphing. If we have a greater than or greater than equal to, this becomes a disjunction, and it does not matter if we have overlapping lines or not. Okay, so we go ahead and graph. Simply, we do this one first because it's got the smaller of the two numbers. We plot down a -4 because this does not have a bar underneath. It's an open circle, and we're shading to the right. This one we plot down the 4, open circle again because it's not an equal to, and we shade to the left. And because this is an and statement, because of less than, we are looking for the overlapping, so we shade in the middle because that's the part we're looking for. You can write this as a conjunction in set notation. Okay. We can also go ahead and check that what are the numbers, what are the integers that would be values in this. So we can write down all the set of integers. It would be -3, -2, -1, 0, 1, 2, and 3. And those all numbers are fit right there in that graph. Okay, here we go. Here's another one. Absolute value sign is by itself. We've got a great or, so it's a or statement, and then a number. Okay, we can go ahead and simply drop the absolute value sign and write everything out the way it is. The second equation, we drop the absolute value sign, switch the direction of the sign, and change the number from a positive to a negative, or change a sign on the number. Okay, we graph each of these individually. Now, there's no overlapping here, but because this is an or statement, it does not matter, and we can go ahead and graph this and then write it in set notation. Start with the bracket x, draw the bar down, and there you got it right there. Okay. Disjunction is always with an or statement in the answer. Okay, we always need to write that or statement right there. Okay. Let's jump down to number 3. Okay. Again, absolute value sign is by itself, so we can go ahead and drop the absolute value sign, write that less than 11, less than or equal to 11, and we know it's a conjunction because of the less than symbol. We write the expression down here again, switch the direction of the sign, and change the sign of the number. Solve, and we get these two equations. Okay. By graphing, we see that we're looking for numbers between -2 and 9, and write as a conjunction like that in set notation. Next one. Okay. We have another number on the same side as the absolute value sign. So what we're going to do is we're going to go ahead and remove the number to the other side by adding it. Okay. Now that we've got the absolute value symbol by itself on this side, this is a great or symbol, so we know this is an or statement. It's a disjunction. Okay. We go ahead and drop the absolute signs, put the 6 there, solve for that, and graph it. Graph it right there. Again, we do the same thing, but we switch the direction of the sign and change the sign of the number. Solve it and graph it. Now again, in an or statement, we're going to have to write the word or in the set notation. Okay. Follow the same steps that we have, but this is an and statement because this is a less than statement. Now look at this. After we've done all the work, we find that there is no overlap, but in an and statement, there must be some type of overlap or some type of common ground between the two graphs. And because there is no common ground, we have no solution that fits this one and fits this one. So there is absolutely no solution to this problem. Again, we work here. This is a great OR statement. Okay, look for 2 is x is greater than 2. Graph that. Okay, x is less than 10. Graph that. Now look at this. By looking at this, we can see that every number on the number line is shaded either from this way or from this way. So that means all real numbers is our solution. Okay, and finally, number 7, follow the same thing. The steps right here. Okay. And if we try moving this negative x to the other side to get x, we can see that x is greater than or equal to 0, and x is less than or equal to x. Okay. By putting in numbers right there, we can see that we're looking for all numbers that are greater than or equal to 0, because this one could mean any number for all real numbers, but since we're looking for the double shaded area, it could only be x is greater than or equal to 0. And so this is what we put in our set notation. Okay, if you have questions, please come see me in class and we'll clarify everything that you need to know.